everybody, I'm Roger. Welcome to today's session. If any questions about the topic, please write to Quay and we will answer after the session. This is a model to help you finding out the solutions and the components to perform the best performance of each vertical market. So people create methodology for the best productivity, specify the technical detail to be a specification for a component. The solution we evaluated for Industrial 4.0 is Industrial Big Data. Of course, the first concern is how to do it. People start to deploy many sensors for data acquisition and connect all sensors to Ethernet. There are also many computers or servers to analyze the collected data and transfer to useful information. This analysis is based on human experience to make relevant combination and the separation of big data, just like the AI robot did in the science fiction. But we ignore one thing: more connectivity means high risk. There are various attacks or intrusions in different purposes and make threats to everyone collect together. In this model, we can see if we make the industrial big data to be solution and specify the Ethernet to be components, the future challenge will be security on Ethernet. This is also well known as cybersecurity. Before we describe how to secure the network, we first talk about how attacks or intrusions make threats in IoT. On this slide, we can see a typical automation model in factory. It's an operational network to connect things and people. We can trace the raw data collected in each process, just like SOP. Then it's learned as arranged data and analyzed based on human experience, finally utilized by people. The key point is people converging the informational and operational technology to make IoT. Industrial IoT comes from here. We can simply set attacks or intrusions follow the data flow to make threats. We will show that on next slide. So where is the data? Where is the threat? What we mentioned about data is like production parameters, sensitive documents, or control signals. Everybody knows TSMC, which is the giant of semiconductor. Behind the high performance and the precise production is a pile of sensitive technical documents. Once IoT making everything connect together, it has many portals to intrude the network. Here we created a threat model to describe how attacks become threats through the IoT infrastructure. In the model, we can see two main reasons we have to pay more attention to security topic in IoT world. The first one is an IoT and IoE world. The second, the convergence of IT and OT is trending to apply to IoT. These two reasons are also a summary of the previous slides and strengthen what we mentioned about the cybersecurity. Let's see in the real world how attacks become threats in an IoT zone. It may occur in famous vendor and its factory, city infrastructure, smart building, or the safe OS first priority transportation. It's more terrible than we thought because each vertical utilizes Ethernet to improve productivity. But it's also becoming a rapid channel to the network for hackers. Okay, let's go through a typical Ethernet network architecture to come out the sense of attacks and intrusions. Specify the line between protect from outside and inside. This could be a major difference of attack direction. It's also considered as the attack is from internet or is from intranet. To protect from outside, we can see the firewall or security gateway is on the top of the tree topology. It's usually a defensive portal of network zone. About this, we will have a follow-up introduction in another webinar session. Here we will focus on switches, the first defense line in network border. It also performs major defense to attack or intrusion outside. The red arrows mean attacks and intrusions. For example, we can connect our laptop to an unused Ethernet port of a switch and easily access the intranet. If network administrator didn't apply any security mechanism to the switch, it will become my super highway to contact what I want. It's pretty easy to people which is familiar with the networking, especially hackers. So we'll spend a little time to describe what security mechanism we can apply to the switches. We classify these as 4 items: user permission, data encrypted, network availability, and deny malicious access. Before explaining these 4 items, we need to know the scope of them. As illustrated on slide, we protect 2 scopes of the network. First, limit all malicious management to the switches, because error configuration of a switch will make the network crazy. Second, prevent the attacks or intrusions go into network. Isolate all possible threats in switch front side. In first scope, most important is creating authentication with username password and keep this in secret. In the second one, we did 2 things: isolate the attacks or storms and limit unauthorized hosts to intrude your network. It's allowed to create multiple user accounts in different levels on AKI switches. If you would like to log in the management interface, the username and the password is required. Except to local storage, AKI switches provide remote authentication through Radius and the TACA servers. The professional AAA protocols enhance the confidentiality of user authentication. It also provides priority of these authentication options. You can choose the different sequence just like TACA's Plus, Radius, then local database. Once the previous option authenticated fail, it will perform the next one automatically until success or total fail. Another useful mechanism is trusted host. Sometimes we would like to make computers or laptops with specific IP address to visit the switch. It's allowed to create a trusted IP list and choose allow service like HTTP, Telnet, or PIN. This means a host not in trusted IP list is not allowed to access the management interface of the switch. Or another case, a host in trusted IP list is only allowed to use the web interface but not Telnet, because we disabled the Telnet service to this host. We believe these 2 features strengthen the access security to the switches, especially protect the network parameters on switches and make network configuration stable. As this word told, it provides coding algorithm to apply the encryption and the decryption to exchange frames between user and the switch management interface. In general, we utilize 3 types of TCP/IP service to configure the switches: HTTP, Telnet, and SMP. The corresponding encrypt protocols are HTTPS, SSH, and SMP v3. This avoids the frames are captured by somebody and the username password is leaked. Another feature about data encrypted is password encryption. It's used when the administrator backs up the switch configuration in PC storage. We will make the password encrypted in this configuration file. It's also an avoidance of data leakage. Please pay attention to the scope icon. It's changed from switch management to network access. What we mentioned about the network availability is only one point: keep network working normally. When we talk about network availability, the typical case is redundancy. It provides alternative traffic paths to keep the continuity of data exchange. So we consider it's very good example to describe what it is. For illustration on the slide, we can see the hacker controls many computers to transmit garbage frames and try to exhaust data server's resource. This is well known as DDoS. If more than 10,000 hosts create more than 100,000 sessions to the data server, this will make the server too busy to provide normal device. What we did to prevent this is identify the garbage frame and drop them. But it doesn't mean we can identify all the DDoS threats, because these frames could carry normal content, not garbage. Another simple way to isolate the network from storm is RAID control and storm control. It's allowed to configure the port rate control on both ingress and egress side, which respectively limit the bandwidth in incoming and outgoing side of the switch. Storm control could be used to limit the storm of broadcast, multicast, and unknown unicast storm. There are two chief questions for this topic. One is how to determine the access is malicious or not. Another one is how to deny it. Here we use the concept of whitelist to put safe binding of my IP MAC port to the list. If a host with its friend has no match in whitelist, it will be considered as unauthorized. Seriously, we will consider the unauthorized access is all on purpose and malicious. So the next step to deal with the friend is dropping them before they are into the network. If you don't want to spend much time to create whitelist on each switch, a DHCP server can help you. The administrator just creates all hosts with authorized MAC address in the DHCP server, configure the respective IP address assignment rule to this host. Once a host is capable to get dynamic IP address from the DHCP server, means this is an authorized host. At that time, the DHCP snooping enabled on switches will put this IP MAC port binding into the whitelist automatically. From static to dynamic and distribution to centralized, IP source guard and DHCP snooping do the same thing to protect the network. If you do know somebody with specific frame pattern is dangerous, you can also utilize access control list to scan all frames and drop the condition match one. This is the concept of blacklist. Both whitelist and blacklist provides network administrator a big flexibility to detect and prevent the threats. Just summarize the feature of Aki Security Pack. For these features, we have clear user guide to instruct how to configure. We also provide more detail about Security Pack if you highly interested for that. Thanks for everybody. Hope you all have a good time.